Okay, good morning and welcome to Mod 5, Lesson 3. Um, we are going to have to shorten the lesson up. It's quite long today, but for the sake of the video, we're really only going to have time to go over one example. And then if you have further questions, you're going to have to see me later. So Mod 5 Lesson 3, we're actually going to start our example. I know it starts earlier, but we're going to start on page 15 with exercise 1, and we're going to go through that entire exercise. And then if you have more questions about it, you can ask me at either before school or at lunch. Okay, so starting with exercise 1 here, it says a linear function has a table of values below, and it already tells you that this is linear. The information in the table shows the function of time in minutes with respect to mowing an area of lawn in square feet. Okay, so before we were able to notice a pattern in the y values and say, oh, this is linear. Well, if you figure out the pattern here or try to figure it out, to get from 36 to 144, you would have to add 108. But you're going to find out to get from 144 to 216, it's adding 72. And to get from 216 to 360, it's adding 144. So our method here that we have been using is now invalid. We know this is linear, but our pattern right here is not the same. And the reason is because if you look at the x values, we're now no longer going up by the same amount each time. Before this, we had like 0, 1, 2, 3, 4. Now, this isn't going up by the same amount, 5, 20, 30, 50, which means that we're not going to be able to use this method. So what we want to do now is we would like to find a different way. So the first thing says explain why this is a linear function. And so we're going to use something called the unit rate to show that this is linear. And the unit rate is then to figure out, okay, if you mow 36 square feet in 5 minutes, how much do you mow in 1 minute? And you would figure that out by going 36 divided by 5. And then if you do that in your calculator, you get 7.2 square feet in 1 minute. Okay, and this is called the unit rate. That's the unit rate for this scenario. And if you check this out with the next value, 144 then, divided by 20, and you do that in your calculator, again, you're going to get 7.2 square feet in 1 minute. And then you check again, 216 divided by 30, again, is 7.2. And guess what? If you do the last one, 360 divided by 50, you'll also get 7.2. So your unit rate here is 7.2 square feet in 1 minute. That's our unit rate. The word unit indicates we're trying to figure out how much we can mow in 1 minute or in 1. So explain why this is a linear function. The unit rates are equal for all pairs. Okay, so this is a new way to figure out if something is linear or not linear. It tells us it is, but we had to explain why. Okay, so we want to flip the page here. And we're actually going to need this table. So you're going to have to either flip back and forth or just trust me on the values. So it says now to describe the function in terms of area, mode, and time. All this means now is we want to use our unit rate to describe it, okay? So we're going to talk about this. As the minutes increase, and I'm just going to use an arrow for space, by 1, we figured out as our minutes increase by 1, our unit rate tells us that our square feet mowed then also increases, and this one increases by 7.2. Okay, so if you describe it, it's just asking you to put your unit rate basically into a sentence. All right, now C, D, E, and F, we actually already answered here. So it asks you, what's the rate of mowing a lawn in 5 minutes? Well, that's what we figured out when we did our division. So if you look at the chart before, in 5 minutes, it said we mowed 36 square feet. And so what we did was we did 36 divided by 5, and we got 7.2 square feet per minute. And then we did it again for 20 and 30 and 50, and each time we got 7.2 square feet per minute. So that's the same answer here, here, and here. We just divided the different numbers to get that. Okay, so let's write the rule that represents the linear function that describes the area in square feet mowed y in x minutes. Okay, first things first, you need to know that the word rule in mathematics is equivalent to the word equation. Okay, so this really, we could say, write the equation that represents this linear function. And if you recall, when we write equations, we've been using this format, y equals mx plus b, where m was our slope. Another word for slope is rate or unit rate. And b was our y-intercept. Well, another way to describe y-intercept is by starting amount. And that's what we're going to be using here in this chapter, is these words are going to show up much more often. So our linear rule, or our linear equation for this situation, should be y equals, our rate was 7.2 x plus, now our starting amount, sometimes you have to think about this intuitively. If you mow for 0 minutes, how much lawn got mowed? Well, 0 square feet. So our starting amount here is 0. So here is our equation. This is our answer. Y equals 7.2x plus 0. Or you could say just y equals 7.2x. Okay, now last but not least on this page, it says now describe the limitations of x and y. And if you recall from the previous lesson, we talked about negative numbers. In this case, that is our limitation. If we put negative value in for x, we're saying negative minutes. We can't have negative minutes. And for y, if we get a negative value out, we're saying we mowed negative square feet of lawn, which is impossible as well. So our limitations are negative numbers. They don't work in this case. Well, they work. They just don't make any sense when you are putting them in the scenario. Okay, next page now. So we're going to go to page 17. To the top again. Okay, it says, what number now does the function assign to 24? That is, what area of lawn can be mowed in 24 minutes? Okay, so what we want to do is we want to use our equation now, y equals 7.2x. And it gives us a new piece of information. It says 24 minutes. Okay, when they give you a new piece of information, you want to decide what that goes with. And so one way to decide 24 minutes, we want to plug that in for either x or y. And so if you look back at your original table, it tells you that minutes are x and square feet are y. So if we go back to our question, 24 minutes, we just saw from the table that minutes are x values. So we are now going to take 24 and substitute it in our equation for x. So we want y equals 7.2 times 24, and that should tell us how many square feet can be mowed, okay? So if you probably need a calculator here, but if you don't, you can just do it. That's fine too. So I get 172.8. So 172.8, y equals 172.8 square feet. Okay, and then the last question here, how many minutes would it take to mow an area of 400 square feet? Okay, so now this time, again, you already wrote your equation, y equals 7.2x. 400 square feet, now we got to decide, is that an x value or a y? So if you go back to your original chart, if you're not sure, it tells you that square feet are y values. Okay, so we're going to put 400 in for y this time, equals 7.2x. And now this one, we don't multiply. To solve this, you would divide. So we're going to divide by 7.2 to cancel it out, and divide by 7.2 here to get our answer. X equals 400 divided by 7.2 is 55. If we round it, 55.6 minutes. Okay, and so we're just applying that. Now, one thing I do want to point out is that before we end the session is that in our rule we have had y equals 7.2x plus 0. This value right here, this starting amount has been 0 a lot. Now, in the questions that follow in the lesson, there are going to be some where your starting amount is not 0. It's going to tell you, like there's a pool question about if you fill this pool up and we already started with this many gallons in, well then that, if they're starting with 35,000 gallons or whatever it is, that 0 is your starting amount. So sometimes it's not going to be 0, but the basic steps for solving them and figuring out the rule are the same. It's just that this right here is sometimes not going to be 0. Okay, I'm sorry that I don't have time to get into other examples, but if you need more help, please come and see me either before school or at lunch, and I will be glad to come help you out.